Alright, so this is the lesson video for Chapter 7, Section 1. So in Chapter 7, we are really going to start focusing on ions. So we started out by learning about atoms separately, the protons, neutrons, electrons. Then we moved into learning about the setup of the periodic table and doing electron configuration and things like that. So now we're really going to focus on ions because where we're headed is getting to when atoms bond with one another. And when they bond, a lot of times it's in the form of ions. So, valence electrons are electrons in the highest occupied energy level. Valence electrons are the only electrons involved in chemical bonding, and elements in the same group have the same number of valence electrons. Alright, so we know that atoms have the same amount of electrons as they do protons, their atomic number, as long as they have not become an ion yet. So for example, boron has 5 protons, so it has 5 electrons. That doesn't necessarily mean, though, that it has 5 valence electrons. Valence electrons are in the highest occupied energy level. And so the good news is it's really easy if you look at this periodic table to figure out how many valence electrons an atom has. So every element in group 1 has 1 valence electron. So if you think back to electron configuration, each element in group 1 ends in something S1. So there's 1 electron in that highest S sublevel. Everything in group 2 has 2 valence electrons. So it ends in something S2. I say something because we don't know if we're at 1S, 2S, 3S, like that. Alright, you skip your transition metals because transition metals, they're a little bit behind. Like if you think about this, we're on 4S here, but here we're only at 3D, so they're not included in our valence electrons. And if you skip over here to group 13, they have 3, and then 14 has 4, group 15 has 5, group 16 has 6, group 17 has 7, and group 18 has 8, except for one of them. There's always got to be an exception, right? And that is helium. Helium only has 2 electrons to begin with. Alright, it's the second element. It has 2 protons, 2 electrons, so it can't possibly have 8 valence electrons. Alright, so helium is the exception, so if you're in my class, I always like to ask you about helium because it's the one exception. So the easiest way to tell how many valence electrons is the group number. So on the periodic table we use in our class, it's group 1 through 18. And so group 1 has 1, group 2 has 2, this is groups 3 through 12, and then when you get 13 through 18, I just say take the 1 off the front. So group 13, if you remove the 1, has 3. Group 14, if you remove the 1, has 4. So the group number is the easiest way to tell. Some periodic tables are set up where this is called group 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, and then these are denoted with a B, a number with a B. That's the kind of older form. The more modern periodic tables have the 1 through 18. But use that group number to help you with that. So electron dot structures are just diagrams that show the symbol of the element surrounded by the valence electrons as dots. So again, this is just kind of an excerpt of the periodic table. So every element in group 1 has 1 valence electron. So if you look, they each have 1 dot. Everybody in group 2 has 2 electrons. So you see 2 dots. Then they skipped the transition metal area. So now we're at group 13. They all have 3 dots, 4, 5, 6, 7, 8, except for who? Helium only has 2. Alright, so if I ever ask you to draw the electron dot structure, you just figure out how many valence electrons and put them as dots. Now if you notice, they have organized their dots in a specific way. I don't care how you pair your dots up, because we won't focus on electron dot structures for single atoms for very long. So I'm not worried about if you sit there and, you know, like see they all have this one on the right of the symbol and then their second one they put above the symbol. I don't care where you put them. I'm just making sure you put the right amount. Some other teachers may be a little pickier than that though. Whoop, I didn't grab a marker. Alright, so it says write the electron dot structure for the following elements. So we have P, which is phosphorus. So hopefully you have a periodic table out. If you don't, you probably want to pause this because you'll want a periodic table today. And so find P, it's phosphorus. If you look on your periodic table, it's in group 15. So if you take the 1 off, it would have 5 dots. And again, I'm not picky about where you put your dots. Some teachers may be, so you would just need to make sure whether your teacher is picky about that or not. Like I said, we won't focus on this very long here. All right, next one is argon. So I would find argon on my periodic table as AR. It's in group 18, so if I take the 1 off, it has 8. So that's what argon looks like. Next one is Mg, magnesium. So if you find magnesium on your periodic table, it's in group 2, so it has 2 dots. All right, and the last one is helium. Helium is in group 18, which would make you think it's going to have 8, but remember, that's our one exception to the rule. Helium is element number 2, so it only has 2. So just be careful. For my classes, I always like to ask helium, because I feel like if you know the exceptions, then you obviously know all of it. All right, so hopefully that's making sense. Let me grab my eraser real quick. All right, and then let's move on. So the octet rule states that atoms tend to achieve a stable configuration when they have 8 valence electrons. So when their outer energy level is full, and we discussed this a little bit in chapter 5 when we talked about stability, that's when atoms tend to be the most stable. So metals tend to lose electrons in order to achieve noble gas configuration, and nonmetals tend to gain electrons in order to achieve noble gas configuration. So the whole thing is you really need to just think about the periodic table. All right, I'm going to draw just a makeshift periodic table, hopefully. I'm not going outside of the video. Okay, so this is just kind of my fake periodic table. So this side are the metals. And then, of course, we have our stair-step line if you've watched the Chapter 6 video. And then these are the nonmetals. And our metals include down here also. So here I'll put a little arrow. All right, so let's look at our charges. In Chapter 6, we discussed what the charges were for each group. So the first one is a positive 1. Second group is positive 2. Remember, the whole middle area is just positive. It could be positive 1, 2, 3, 4, 5. When we get over here to group 13, it's positive 3. Group 14 is plus 4 minus 4. Group 15 is negative 3. 16 is negative 2. 17 is negative 1. And group 18 is 0 because they already have a full outside energy level. So if you notice, the metals tend to have the positive charges. So that means they tend to lose electrons. And the nonmetals have the negative charges. So that means they tend to gain electrons. So a cation, as we've already discussed, is a positive ion. Remember, the T in positive kind of looks like a plus sign. So that means it has lost electrons. When you write the electron configuration for a cation, you write the electron configuration for the original atom, and then you take away the number of electrons from the highest energy level. Okay, this is why, I'll show you in just a minute, why I make my students rearrange and put the sublevels in order when we do standard configuration. When you name a cation, the name of the element does not change. So Ca is calcium. Ca with a positive 2 charge is called calcium ion. Okay, so you can see calcium's right here. It has a positive 2 charge. The sooner you learn those charges from the periodic table, the easier your life is going to be for the next probably 3 chapters. So let's look at some electron configuration. So I went ahead and put up the periodic table from chapter 5. So let's see what elements we're doing. So we're going to do Sr with a positive 2 charge and iron with a positive 3. So right here, I just want to point out that I put 2 positive and here I put positive 3. That's because depending on what resource you're using, you may see it written either way, 2 positive or positive 2. They mean the same thing. Okay, so don't get hung up on, oh my gosh, what's 2 positive mean? Or, you know, like sometimes you'll see positive, 2 positive, 3 positive. Sometimes you'll see it as positive 2, positive 3, like that. All right, so we have Sr with a positive 2 and Fe with a positive 3. So I'm going to go back to my periodic table. All right, so let's go ahead and relabel this periodic table. All right, so remember, our yellow are our S. So we have 1s, 2s, 3s, 4s, 5s, 6s, 7s. Our red are our P, so remember S starts with 1, P starts with 2. So we have 2P, 3P, 4P, 5P, 6P. If you have anything down here, you can label that as 7P. D starts with 3, and D is in the middle, so we have 3D, 4D, 5D, 6D, and F starts with 4, so I have 4F and 5F. All right, so hopefully you still have your periodic table from Chapter 5 that's labeled this way, but if you don't, it'd be a good idea to label a new one. All right, so let's knock out our strontium with a positive 2 charge. So I find strontium, SR, right here. Okay, we're just going to do a standard configuration because arrow takes a little bit longer. All right, so remember, we're going to start up here at hydrogen. Now, if you're not understanding how to do electron configuration, you need to go back and watch the section 5.2 lesson videos. There's 2 of them before you watch this one because I'm not going to kind of re-explain everything. I'm going to assume you already know how to do it, and we're just going to focus on what the difference is in the charge. All right, so we start at hydrogen, so that's 1s2. Then I'm at lithium, 2s2. I'm at boron, 2p6. I'm at sodium, 3s2. I'm at aluminum, 3p6. I'm at potassium, 4s2. I'm at scandium, 3d10. I'm at gallium, 4p6. And then I'm at rubidium, 5s. And then I go 1, 2. So 5s2. All right, so next thing I'm going to do before I focus on the charge is I'm going to rearrange my sublevels. See, I have my 1, 2, 2, 3, 3, 4, 3. So I'm going to swap these 2, 3d10 and 4s2. All right, so now I have my electron configuration for strontium. But this isn't just strontium, it's the ion. It has a positive 2 charge. So what does positive 2 mean? It means it lost 2 electrons. So I go to the highest energy level, which in this case is the 5, energy level 5, highest sublevel is 5s, and I remove 2 electrons. So in other words, I can get rid of 5s2. Now some of you just like to cross it out, which is fine. Some of you like to erase it, which is also fine. It doesn't matter, just make sure I know that you realize that there are no electrons in 5s anymore. And then it also says to name it. Well, since this is a positive ion, the name doesn't change. So it's just called strontium ion. All right, now you may think, well, why in the world did we waste time rearranging? That wouldn't have changed our answer. Well, when we get to iron, you'll see why. All right, so let's move on to iron. So we have Fe with a positive 3 charge. So again, I'm going to start at hydrogen. So I have 1s2, lithium is 2s2, boron is 2p6. Oop, I didn't circle my element for y'all. There you go. Sodium is 3s2, aluminum is 3p6, potassium is 4s2, scandium is 3d, and so then I count across 1, 2, 3, 4, 5, 6. So 3d6. So what does positive 3 mean? Well, positive 3 means it loses or has lost 3 electrons. So you must take them out of the highest sublevel. Well, if you look, a lot of you may be tempted to say, oh, well, obviously it just becomes 3d3. I just removed 3 of them. But 3d is not the highest energy level. 4s is. So that's why I make my students rearrange. Okay, so let's start by rearranging. So I'm going to rearrange 3d6 and 4s2. Because now I can see the correct arrangement. All right, so I need to lose 3 electrons. So if I get rid of 4s2, that's only removing 2 electrons. I still need to remove another one. So you just move to the next sublevel. So instead of ending in 3d6, I would just change that to 3d5. So see, now I removed 2 from 4s and 1 from 3d. So I've removed 3. All right, and then what do we call this? Well, since it's positive, we don't change the name. So it's just an iron ion, just like that. All right, so for positive ones, make sure that you have rearranged. You remove whatever you need to remove to take care of the charge, and then the name does not change. All right, so let's look at, well, what happens then if we have negative? All right, I'm going to leave this up here real quick just so that way I don't have to rewrite it for y'all next time. Well, oh, we have two more apparently. All right, so y'all pause the video real quick and try these two. So we have zinc with a positive 2 and sodium. Whenever you just see a positive or negative, that's an understood 1. So sodium with a positive 1 and zinc with a positive 2. So pause the video real quick and then we'll look at those. All right, so I'm going to assume that you got it. And let's look at these. So we have zinc positive 2. So zinc's right here. So I'm going to start at hydrogen, so it's 1s2, lithium, 2s2, boron, 2p6, sodium, 3s2, aluminum, 3p6, potassium, 4s2, and scandium, 3d, and then when I count across, it is 10. All right, so positive 2, of course, means it has lost 2 electrons. So remember, I'm not going to pull them from 3d10. I'm going to rearrange first and then pull those 2. So I'm going to do 3d10, 4s2. I need to remove 2, so I'm going to get rid of my 4s2. And then once we name it, remember, since it's positive, the name doesn't change. So it would just be called zinc ion. So hopefully you got that one right. Okay, so let's move on and look at our other one that hopefully you've already tried. If not, pause the video and try it. Remember, you got to be able to do these on your own. So we have sodium with a positive 1 charge. Like I said, the 1 will be understood for charges. So we start at hydrogen. So we have 1s2, boron, lithium, 2s2, boron, 2p6, and sodium, 3s, and I only need 1 because I'm not trying to get to magnesium. 3s1. I don't need to do any kind of rearranging. They're already in order of 1, 2, 2, 3. And so what does a positive charge mean? It means it lost 1 electron. So I go to the very end. I'm going to get rid of 3s1. So there's my electron configuration. And since it's positive, the name does not change. So it's just called sodium ion. All right, so hopefully you got both of those right. Don't forget to rearrange. All right, so let's move on now to the negative ones. And see, there's the 2 that we just did. All right, so like I said, I'm just going to leave my little notes up there to kind of save time. All right, so anions, on the other hand, are negatively charged, which means they have gained electrons. When you write the electron configuration for anions, you write it for the regular atom, and then you add the correct number of electrons. When you name an anion, you change the ending to I. So when we name a negative ion, we actually have to change the name a little bit. So Cl is chlorine. Cl with a negative 1 charge is chloride ion. Okay, so that's where you get things like sodium chloride. The sodium has a positive charge, and the chlorine has a negative charge, so it becomes chloride. All right, so let's see which elements we're going to do. So we're going to do phosphorus with a negative 3 and fluorine with a negative 1. So let me go back real quick. All right, so we got, went back too far. So phosphorus with a negative 3 and fluorine with a negative 1. So I find phosphorus right here. I start at hydrogen, 1s2, lithium, 2s2, boron, 2p6, sodium, 3s2, aluminum, 3p, 1, 2, 3. All right, so what does, first of all, I don't need to rearrange, 1, 2, 2, 3, 3. What does a negative 3 charge mean? It means it gains 3 electrons. So I just go to my last sublevel, which is 3p, and I add 3. So instead of ending in 3p3, it's going to end in 3p6. Now when I name it, since it's negative, instead of being called phosphorus, it's going to be called phosphide. Now I know some of you might be like, well, I thought it was going to be phosphoride. When you are at the beginning stages of naming, which is right now, if you put the I kind of at the wrong spot, I'm not going to count it wrong. I'm going to see if you wrote phosphoride, I'm going to realize you knew the ending needed to be I'd, and I'm still going to mark it right. Okay, you'll get used to the fact that phosphorus becomes phosphide. It just takes some time. All right, so let's look at our other one, which is fluorine with a -1 charge. All right, so we're going right here. So I start at hydrogen, which is 1s2, lithium, which is 2s2, boron, which is 2p, 1, 2, 3, 4, 5. So what does a -1 charge mean? It means it gains 1 electron. All right, so I go to the end, it gains 1, so instead of 2p5, it ends in 2p6. And then instead of being called fluorine, because it's negative, it's called fluoride, ion. So don't forget that "ide" ending. And remember, just a side note, that fluorine is F, not Fl, as its symbol. All right, so let's see which two you get to try real quick. Let's see. Probably should have written these down beforehand. Sorry, there's lots of clicking on this one. Didn't think this through all the way. All right, there's the two we just did. So you're going to try bromine with a -1 and sulfur with a -2. Okay, so pause the video real quick and try bromine -1 and sulfur -2. I'll assume you've already done that now. So we have bromine with a -1 charge. So we're right here. All right, so I'm going to start at hydrogen, 1s2, lithium, 2s2, boron, 2p6, sodium, 3s2, aluminum, 3p6, potassium, 4s2, scandium, 3d10, and gallium, 4p, 1, 2, 3, 4, 5. All right, so on this one, I do need to rearrange 1, 2, 2, 3, 3, 4, 3, 4. I need to switch 3d10 and 4s2. All right, so what does the -1 charge mean? It means it gains 1 electron. So I go to the end, 4p5 becomes 4p6, and then of course I have to change the ending. So bromine becomes bromide ion. All right, so hopefully you got that one right. So let's move on. Our next one is sulfur with a -2 charge. All right, so I start at hydrogen, 1s2, lithium, 2s2, boron, 2p6, sodium, 3s2, aluminum, 3p6. Oops, sorry, we're stopping here. I was ready to just keep on going. So 3p, 1, 2, 3, 4. All right, so I don't need to rearrange 1, 2, 2, 3, 3, so it's good to go there. But what does -2 mean? It means it gains 2 electrons. So instead of being 3p4, I'm going to add 2 more. It becomes 3p6. And then instead of being called sulfur, because it has a -2 charge, it's called the sulfide ion. And so again, some of my students, especially in the beginning, they'll want to call it sulfuride, which is fine in the beginning. You will get used to the fact that it changes to sulfide. All right, so let's move on. And hopefully you liked electron configuration out of chapter 5, and so you think this is all super easy. All right, so let me click back through all the stuff we just went through. And so here are the last two that we just did. All right, so section assessment. How can you determine the number of valence electrons in an atom of a representative element? Well, it's based on the group number. Okay, just remember for groups 13 through 18, you take the 1 off the front, so it becomes 3 through 8. So it's based on the group number. Atoms of which element tend to gain electrons? So if you look, positive ions have lost electrons. Negative ions have gained, so who tends to gain? Nonmetals. Okay, so this one's nonmetals. Then it says atoms of which elements tend to lose electrons? Well, positive charges have lost electrons, and so those are our metals. So nonmetals tend to gain, metals tend to lose. So how do cation ions form? Well, cation ions are positive ions, so they have lost electrons. So an atom has to lose electrons to become a cation. And then how do anions form? Well, anions are negative ions, so it's had to gain electrons. Remember, don't think of positive and negative as addition and subtraction, because then you'll do them backwards every time. All right, so number 5 and 6 are kind of related to one another. So in class, normally I just do them together, because number 5 says how many valence electrons are in each atom, and then number 6 says draw the electron dot structure for each atom. Well, that tells how many valence electrons. So we're just going to kind of do number 6 and number 5 together. So potassium, first of all, what's the symbol for potassium? It is not P, it is K. So you find K on your periodic table. It's in group 1, which means it has a 1 valence electron. Next one is carbon. Carbon is C. If you find C on your periodic table, it's in group 14, which remember we take the 1 off, so it has 4 valence electrons. Remember, I'm not picky about you separating all 4 of them. We will do this for a very short period of time. I know some of you, if you're a teacher and you're watching this, you may be cringing. That's fine. But we rarely stick with this method for very long. All right, so magnesium is Mg. It is in group 2, so it has 2 valence electrons. And then the last one is oxygen, which is O on the periodic table. It is in group 16, so it has 6 valence electrons. All right, so that tells me how many valence electrons, and I did electron dot structure for each. All right, so let's move on to our last couple of questions. So how many electrons will each element gain or lose in forming an ion? So again, hopefully you have labeled the charges at the top of your periodic table until you get them memorized. All right, so calcium is in group 2, which means it has a positive 2 charge. Okay, so what I'm going to do is I'm just going to write this symbol. It would have a positive 2 charge. So what happens to get a positive 2 charge? You must lose 2 negatives. So it has to lose 2 electrons. All right, so fluorine is F. If you look on the periodic table, it's in group 17, which falls under the -1 category. So how does something become negative? It has to gain electrons. Since it's -1, it gains 1 electron. All right, next is aluminum. Aluminum is Al on the periodic table. So when you look, it's in group 13, so it ends up having a positive 3 charge. So how does it do that? Well, to become positive, you have to get rid of some negatives. How many negatives? In this case, 3. So it must lose 3 electrons. And then last one is oxygen. Oxygen is O on the periodic table. It's in group 16, which lines up with the -2 charge. So how does it become that way? Well, it has to gain 2 negatives, or gain 2 electrons. All right, so hopefully you're understanding how the charges work. A lot of people get that backwards. So remember, call electrons negatives if that helps you keep them straight. All right, so number 8, it says write the name and symbol of the ion formed when a potassium atom loses 1 electron. Well, if a potassium atom loses 1 electron, potassium, first of all, is K. Let's write the symbol. And if it loses 1 electron, it has a positive 1 charge. So we call it K positive. Well, it also wants the name. Well, since it's positive, we don't change the name. It would just be called potassium ion. All right, part B, it says a zinc atom loses 2 electrons. So zinc is Zn. If it loses 2 electrons, that means it's lost 2 negatives, so it has a positive 2 charge. Since it's positive, we don't change the name. It's just zinc ion. Then last one, it says a fluorine atom gains 1 electron. So fluorine is F, not Fl. If it gains 1 electron, it becomes negative. And remember, when we name a negative ion, we change the ending to I. So instead of being called fluorine, it's called the fluoride ion. All right, and so then the last one says write the electron configuration of cadmium, which is Cd, with a positive 2 charge. So I'll put another periodic table up right after this slide. So we're going to do Cd with a positive positive 2 charge. I'm not going to relabel all my sublevels. Hopefully you have those labeled on your periodic table. All right, so let's knock this one out. So we have hydrogen, which is 1s2, lithium, 2s2, boron, 2p6, sodium, 3s2, aluminum, 3p6, potassium, 4s2, scandium, 3d10, gallium, 4p6, rubidium, which is Rb, 5s2, yttrium, which is Y, 4d, and then if you count all the way across, it's going to be 10. Now, before we focus on that charge, I have 2 spots where I need to rearrange. Let's see, it goes 4s and then 3d, 5s, and then 4d. So I'm going to go ahead and rearrange those. So it's going to be 3d10, and then 4s2. It's going to be 4d10, and then 5s2. All right, so what does a positive 2 charge mean? That means it lost 2 electrons. So I go to my highest sublevel, which is 5s2, and I'm going to get rid of that one. All right, so hopefully you're understanding electron configuration. Hopefully you got it in chapter 5, so hopefully this adding of the charges is not that big of a deal. And hopefully ions will continue to be easy, because the easier it can be in this chapter, the easier it makes your life later on in this year.